Jai Hind to all. My name is Dr. Divya Sharma. I am taking this video lecture on 7.4 IC op-amp that I will discuss in 7.4 ICAM, that is General Operational Amplifier Stages. This topic is from Integrated Circuit and its AKTU code is KEC 501. First, what do you mean by integrated circuit? All the electronic components that are interconnected on a single chip, that is known as integrated circuit. That electronic components that may be active components or active devices or passive devices, and integrated circuit are usually called IC or chips. Now I will discuss this. Electronic components are two types, that are active devices and passive devices. Now active devices are what? Active devices are transistors, diodes, etc. and passive devices are capacitor, resistor, etc. Now it is formed as a single unit by diffusing impurities into single crystal silicon, which then serves as a semiconductor material. Now what is scale of integration? Now scale of integration, that is classified in 5 types. That is, first is SSI, means small scale integration. In this small scale integration, about less than 100 components are, or you can say about 10 gates are there in small scale integration. Second is medium scale integration. In medium scale integration, less than 500 components are there, or you can say more than 10 or less than 100 gates are there on a single chip. Now LSI, it stands for large scale integration. In this, here components are in between 500 to 3 lakh or have more than 10 gates are there. Now the fourth one is very large scale integration. So in very large scale integration, more than 3 lakh components per chip. Now the last one is VVLSI, very large scale integration. So more than 15 lakh components per chip are there. That is known as very large scale integration. So this is the classification of scale of integration while we are designing a chip. So there are 5 types. Now integrated circuits work. IC can work on a low voltage, can handle limited power of limited amount of power. They are very small in size, they are cheap, and complex circuitry on a chip may be used to obtain improved performance characteristics of an IC. Now basics of IC 741. Now these are the manufacturers of IC 741. It is possible to identify the manufacturer by looking at the number of printed on operational amplifier IC. So Fairchild first produced it and sold it as a mu ampere 741, or where mu A represents the initial for Fairchild and 74 as op-amp. Now Fairchild, that is mu ampere 741, then National Semiconductor, then Motorola, then RCA, Texas Instrumentation, Signetics. So these are the manufacturers of IC 741. Now this is the pin configuration of 741 IC. How many pins are there? 8 pins are there. First represents offset null. Second is inverting input. This is the second pin, so it is used as inverting input. And the third pin is used as for non-inverting input, and the fourth one is minus VEE, or you can say minus VCC. This is negative voltage, this is plus VCC. So here 4 is used for minus VCC and 7 is used for plus VCC. 5 is used as offset null, as we have done for the pin 1. So it is used as same as we are using pin 1. Now 6 is used for output, 7 is plus VCC, and 8 is not connected. Let it be you are drawing an operational amplifier. So inputs are connected to 2, 3 and output is connected to 6. Okay, so this is the pin description of 741 IC. So this IC is a 8-pin IC in a dual inline package. This is one of the oldest and one of the most popular op-amp IC. Its performance, it's a high performance monolithic operational amplifier. It is used for wide range of applications such as integrator, differentiator, summing amplifier, instrumentation amplifier, etc. Now, this is the pin description of 741 IC. Pin 1 is used for offset null. So, offset voltage is nulled by application of an voltage of opposite polarity to the offset. Now, pin 2 is inverted input. All input signals at this pin will be inverted at output pin 6. Now, pin 3, this is used as non-inverted input or non-inverted input. All input signals at this pin will be processed normally without inversion. Now, pin 4 minus V, that is minus V pin, also referred as VCC, means why VCC you can use it, is negative supply voltage terminal. There are two supply voltage terminals, that is plus VCC and minus VCC. So, here you are using this minus VCC for pin 4. Now, pin 5 offset null, that is same as it is used pin 1. Now, pin 6 is used for output signal polarity will be opposite to the inputs when this signal is applied to the operational input inverting amplifier input. Now, pin 7, that is plus VCC. So, plus V pin, also referred as VCC, is positive supply voltage terminal of 741 operational amplifier IC. Now, the last pin is pin 8, that is of 741 pin 8. Now, this is not connected. NC stands for not connected. There is no other explanation. There is nothing connected to this pin. This is just there to make it as a standard 8-pin package. Now, these are the important characteristics of IC 741. So, first here input resistance, its value for IC 741, that is 2 mega ohm, ideal value it's infinite. Output resistance, that is 75 ohm, and its ideal value is 0. Now, voltage gain 2 into 10 to the power 5 and its ideal value is infinite. Bandwidth 1 megahertz and ideal value of bandwidth is infinite. Now, slew rate 0.5 volt per microsecond and its ideal value is infinite. So, there are many characteristics are also there, that is let it be that is CMRR, common mode rejection ratio, and so on. So, this is the block diagram of operational amplifier. So, here mainly there are 3 stages. This one is first input stage, this is your intermediate stage, this is your output stage. So, in intermediate stage there are 2 stages are also defined, that intermediate stage and buffer and level shifting stage. Now, what is the working of all these block diagrams which are present in this block diagram of operational amplifier? First, if we are covering this first input stage, this is here we are giving inputs from these 2 terminals. So, here 2 terminals at the input side and 2 terminals are at the output side. So, this is dual input balanced output differential amplifier. Here, what is the working of this input stage in this operational amplifier? It rejects the noise from the input signal and it provides high input impedance and provide high voltage gain. So, this is the working of input stage. Now, the next is intermediate stage. Now, here you can see 2 inputs are there and 1 output is there. So, it is used as its purpose is there, that it is dual input unbalanced operational amplifier. It provides high voltage gain. Now, the third one is block is buffer and level shifting stage. So, it is also known as emitter follower. Its gain is 1 and here it is high input resistance, low output resistance, avoid loading effect and set DC level to 0. So, this is the working of buffer and level shifter stage. Now, the last one is output stage. You can say this is complementary push-pull amplifier. Here at the output of operational amplifier decrease output impedance, increase voltage swing, output voltage swing and raise the current supply to the output. So, this is the working of block diagram of this operational amplifier. Now, 741 operational amplifier circuit. Here are 5 stages are there. So here we will study the internal structure of 7/4 operational amplifier, where there are 5 stages are there: bias circuit, short circuit protective circuit, input stage, second stage, and operational and output stage. So here this is the internal circuit of 7/4 operational amplifier. Here you can see this is your reference bias circuit, where there is Q11, Q12 is present. These two transistors are diode based transistors, Q11 and Q12. Now this is your first stage, where there you can say this is reference bias circuit, and these, now here you can see these two are your current mirrors, Q12, Q13 and Q8, Q9, Q11 and Q10. So these 3 are current mirrors, and these 3 current mirrors, this one and this one, these 3 will help you in biasing this input stage. So input stage is here, this one is your input stage, Q1, Q2, Q3, Q4, Q5, Q6 to Q7. It means Q1 to Q7 comes in the category of input stage. So these 3 current mirrors will help this biasing. These 3 current mirrors help in biasing this input stage. Now here you can say these 2 works as an emitter follower here, and this one is also these 3 transistor with these 3 resistance. These are your, you can say this is a load circuit. Okay. Now this is your second stage, where you have transistors Q16 and Q17, and it is also works as an emitter follower. So it works as an emitter follower and give high input stage and avoid the loading of the input stage, and also increase the symmetry and CMMR. Now the next is here, this is your reference circuit, this is your input stage, this is your second stage, where there is a capacitor of 30 picofarad. This is used for compensating the frequency. So it is frequency capacitor. Okay, and it is connected in the feedback of this second stage. Now here this is the output stage, where there is Q14 and Q20 transistors are connected. This is your output stage, and Q15, Q21, Q24, Q22, this one Q15, Q21, Q24, Q22, these transistors are worked as short circuit protective circuit. So what is the working of this short circuitry protective circuit? Normally it is off and conduct only if one attempts to draw a large current from operational output terminal. So it only works when if there is large current at the output, so it will balance the current. So it is used here. Now here this is also Q19, Q18, Q23 also works in the part of output stage. Now here Q23, it is also, you can say it is also an emitter follower. It works as an emitter follower and it avoids the load of this second stage. Okay. Now, so how many stages are there in this internal structure of operational amplifier? Reference circuit, reference bias circuit, This one is input stage. This is your second stage. This one is your output stage, and this one is your short circuit protective circuit. So 5 stages are there in this internal structure of operational amplifier. Now here you can see this is the transistor Q13, in which you have bias emitter junction that are parallel to each other. Means if you are considering here Q13A and Q13B, so Q13A emitter base junction is parallel to Q13B. Now here also you should know, you have to see that current is proportional. Here current is in proportion of 0.75 and 0.25. So here if you are considering current for this case Q13A, that is equal to 0.75. So here for this one this is 0.25. So 2 proportional currents are there across this Q13 transistor. Okay. Now here, so at the output of operational amplifier, what is the working? So this is the internal structure of operational amplifier, and output of this operational amplifier is low output resistance, and large power, and third one is you have this power AB amplifier. AB class amplifier is there. So here it is efficient class AB output at this output stage of this internal structure of operational amplifier. So here now see, in reference bias circuit, Q12 transistor, Q11 transistors take part in this reference bias circuit. Now here 3 current mirrors are there, Q13 and Q12 and Q8 and Q9, Q11 and Q10 also, here also current mirror. So these 3 current mirrors are used for as a biasing for this input stage. Now input stage transistors are Q1, Q2, Q3, Q4, Q5, Q6, Q7. Now here resistances are connected. R1 is 1 kilo ohm, R2 is 1 kilo ohm, and here R3 is 50 kilo ohm. Now this is you all know, as you have done in the analog circuit subject, that it is already you have studied this circuit, that is Widlar current source. So output of this current is represented as IC10, and here this is IC10, that current is used in biasing of this input stage. And if you are getting current across this current mirror, that is also helps in this in the biasing of this input stage. And this current, if you are getting this current through this transistor, you are getting current, so this will also help in this in the biasing of this input stage. So these 3 current mirrors help in biasing of this input stage. Here this is the current I reference, that is there is collector current of this Q13 diode transistor. Okay, so this is your internal circuit of 741 IC, in which you have different stages. 5 different stages are there. First is reference bias circuit, second is input stage, third one is second stage, and the fourth one is your short circuit protective circuit, and the last one is output stage. Okay, now in internally, if you want to discuss that this is the second stage, Q16 and Q17 transistors are there with this feedback capacitor, that is 30 picofarad. This is the output stage where you have Q14, Q20 transistors are there, and biasing is provided from this Q30, means if you are getting current here, that is that comes to this output stage. And this is also these transistors are also considered in this output stage Q19, Q18 and Q23. Here resistance is R10, that is 40 kilo ohm. Now short circuit protective transistor is Q15, Q21, Q24 and Q22. So this is your short circuit protective circuit that is used to avoid large current at the output stage. So this is the internal structure and working of this internal structure of this 741 operational amplifier. Now here initially IC 741 was manufactured by Fairchild Corporation. In the internal structure of 741 operational amplifier, how many transistors are there? 24 transistors, 11 resistors and 1 capacitor is there used as a frequency compensator. Now here 74 IC requires 2 power supplies, plus VCC and minus VE. Now here plus VCC, its value is plus 15 volt and minus VE, its value is minus 15 volt. Now this 741 IC is capable of operating at much lower power supply, that is up to plus minus 5 volt. Now this is the bias circuit. Already it is discussed in the internal structure of operational amplifier, where there are 2 diode transistors are there, Q11 and Q12, and resistance across this, that is R represent as R5 and that is of 39 kilo ohm. Current across this, that is represented as I reference. Now so this is the bias current of 741 IC. So I reference is generated in the branch at the extreme left of the figure, that is left side of the internal figure. So this is the reference bias circuit. Now this is the Widlar current source. Already we have discussed in the internal structure that we have 2 transistors Q11, Q12, transistor Q11, Q10 and R4 resistor is there, and here this is minus VE. This is current I reference current which is flowing through towards this IC collector current of this Q11, and this is the collector current of this Q10, that is represented as I10. So this is the Widlar current source here. Now this is the another current mirror followed by Q8 and Q9 transistor, which is responsible for biasing in the first stage. Already we have discussed. Now Q13 is a double collector lateral PNP transistor, and the transistor Q12 and Q13 form a 2 output current mirror. Collector 213A provides the bias current for the output stage of the operational amplifier. The purpose of Q18 and 19 is to establish the 2 voltage drops between the bases of the output transistor Q14 and Q20. Now short circuit protection circuitry. Here 7-4 circuit includes large number of transistors that are normally off and conduct only when large output current is required. The large current can be achieved at the output terminal if the output terminal is short circuited to one of the 2 supplies. At the output of the 7-4 IC, there should be large output current at the output side. So here this is the working of short circuit protective circuit. It is means transistors of that short circuit protective circuit are normally off and conduct only when large current output current is required. This circuit protects the IC if an excess load current is drawn from the output of the operational amplifier. The short circuit protection network consists of R6, R7 resistance. These are the transistor Q15, Q21 and Q24, and R11 and R11 resistor and Q22 transistor. These are resistance and transistors are present in short circuit protection network. Now next is input stage, where you have transistors Q1 to Q7. The biasing is performed by transistors Q8, Q9 and Q10. Transistor Q5, Q6, Q7 and resistors R1, R2, R3 from the load circuit of the input stage. Every operational circuit uses a level shifter. The function of the level shifter is to shift the DC level, that is of the operational amplifier output, that swings at the output as positive or negative. Now 7-4 IC level shifting is done in the first stage using the lateral PNP transistor Q3 and Q4. Now second stage, or you can say intermediate stage, is composed Q16, Q17, Q13 B transistors and two resistors that are R8 and R9. So these are the transistors and resistance are composed in the second stage, or you can say intermediate stage. Here transistor Q16 act as an emitter follower in this operational amplifier, and so it provide high input resistance to the second stage, and this minimizes the loading on the input stage and loss of gain, and avoids the loss of gain. Now transistor Q17 act as a common emitter amplifier with 100 ohm resistor in its emitter. Now its load is composed of the high output resistance of the PNP current source Q13B in parallel with the input resistance with the output stage. The output of the second stage is taken at the collector of Q17. This is the capacitor which is present in the internal structure of this operational amplifier that is used to compensate frequency, and it is represented as CC, is connected in the feedback path of the second stage to provide frequency compensator. Now capacitor CC is very small in value. The chip R for capacitor CC that is represent CC is about 13 times that of a standard NPN transistor. Now this is the description of output stage, that 74 IC uses class AB output stage. The purpose of the output stage is to provide amplifier with the low output resistance. Now emitter follower circuit is a class A output stage, and drawback of this class A is a large power dissipation in the transistor. So here, because of this drawback, we are using here class AB class AB amplifier at the output stage. Now the power dissipation can be reduced by arranging the transistor to turn on only when an input signal is applied. So these are your class A, class B, class AB amplifiers. So there are 4 types of class amplifiers are there: class A, class B, class C and class AB amplifier. So this is your class A amplifier, this is class B amplifier, and this is power AB amplifier. This is your emitter follower is a class A output stage, this is class B output stage, and this is the output of class B output stage fed with an input sinusoidal. Observe that crossover distortion is there. So this is the drawback, so that we are using here AB class amplifier at the output stage of this amplifier, 74 IC operational amplifier. So in order to reduce the power dissipation, 2 transistors are required, and NPN to source the output current and a PNP transistor to sink the output current. Now this kind of arrangement is called class B output stage. So both transistors will be cut off when Vi is equal to 0, and Vi goes positive, Qn conducts while Qp remains off. Now when V1 goes negative, transistor reverse roles, and class B output stage is efficient in power dissipation, but the output signal is distorted in class B amplifier. Output signal is distorted when magnitude of Vi is less than about 0.5. Neither of the transistor will conduct, so this is known as crossover distortion. Now crossover distortion can be reduced by biasing the output stage of the transistor at low current. In this case, output stage transistor will remain conducting when Vi is small. Now what are the standard device parameters are there? For the standard NPN, how many transistors are there, NPN or PNP? So for the standard NPN and PNP transistors, the following parameters will be used. For NPN, here saturation current that is equal to 10 to the power minus 14 ampere. Its beta value is 200. VA is equal to 125 volt. Now for PNP transistor, saturation current is same as we have discussed in the NPN, that is equal to 10 to the power minus 14 volt, 14 ampere. Beta is equal to 50. For PNP transistor, VA is equal to 50 volt for PNP transistor. Now 741 circuit, the known standard devices are Q13, Q14 and Q20 in the internal structure of 74 operational amplifier. Now for transistor Q13, ISA, saturation current for A, there are two transistors in the internal structure of operational amplifier, that is Q13A and Q13B. So saturation current for Q13A, that is represented as ISA, and saturation current for, sorry, this is A and this one is B. So saturation current for Q13A, that is ISA, that is equal to what? That is 0.25 into 10 to the power minus 14 ampere. Now for saturation current for this transistor Q13B, that is equal to, that is represented as ISB, and its value is equal to 0.75 into 10 to the power minus 14 ampere. Because these two currents, means saturation current for A and B, are in proportion of 0.75 and 0.25. So here for saturation current for transistor Q13A, that is 0.25 into 10 to the power minus 14 ampere, and in proportion of 75%, that is ISB 0.75 into 10 to the power minus 14 ampere. Now transistor Q14 and Q20 have an area 3 times that of the standard device. Now thanks.